I'm here with Steve Shadders of nChain. You are the CTO of nChain. Is that correct, Steve?
Yes, that's one of my titles.
Okay.
The other one is Technical Director of the Bitcoin SV Node project.
Okay, and that's sort of the one that I'm really interested in talking with you about today. So, do you want to maybe just explain what that is? I mean, what is your role with respect to the Bitcoin SV Node software?
Okay, so I should probably maybe explain how the Bitcoin SV project came to be. It involves three parties. So the project was formed at the request of CoinGeek Mining Operation and funded by them. However, being an open source project, they didn't want to own it. So the owner is actually the Bitcoin Association. And it is nChain that provides all of the technical services. So I am the technical director of the project. I suppose that would make the product owner would be Jimmy as president of the Bitcoin Association. But we pretty much handle all of the day-to-day work of the SV project.
Okay. So you're basically at the top of sort of an organization to write the node software. Is that a fair way to explain it?
Yeah, write, maintain, and fix it so that it can scale. That was, I guess, one of that was the role that we started off with. I think what we didn't anticipate was having a role in supporting all of a large part of the infrastructure within the Bitcoin ecosystem. Because I mean, when Bitcoin SV was formed, we were still a part of Bitcoin Cash. So I think it kind of changed in unanticipated ways.
Yeah. Okay. So maybe can you talk about? Okay, so there's going to be this major upgrade called Genesis. Do you want to just maybe explain? I mean, what is Genesis and why is this significant?
Actually, I was reading through a document that someone else had written about Genesis just a few minutes ago, and it finally dawned on me, and I wish I'd thought about this 6 months ago, that we shouldn't be calling this one a protocol upgrade. We should be calling it a protocol restoration. So the name obviously stands out because the word Genesis has got a pretty particular meaning in Bitcoin. It's the first block that was ever mined. And a point of choosing that name was that it's quite a significant set of consensus protocol changes that are all geared toward the direction of restoring the protocol back to the way that it actually was originally. So none of these changes are really adding anything new to Bitcoin. Most of them are taking something out or putting something back in that had been previously taken out.
Yeah. Well, okay. So I have sort of two follow-up questions to that. One of them is philosophical, which is like, why go back to the original protocol? And then another one is technical, which is, what does that mean exactly to go back to the original protocol? So what do you think?
Well, the first one I think is easy because I'm pretty sure it works. And the reason why I'm pretty sure it works is not necessarily through experience of it working, because back when, the last time the Bitcoin software implemented the protocol as described by Satoshi, there simply wasn't the volume around to see if it worked or not, to give it a real life test. And when I say worked, I don't just mean technically, can it physically handle a high volume of transactions? I mean, worked also in the sense that it does affect miner behavior through its incentive model in the way that we expect. And we've definitely seen some evidence of that already. On the technical side, we have the scaling testnet, which no previous incarnation of Bitcoin ever really had. And I mean, right now, the scaling testnet, its comfort level is humming along at about 1,000 transactions per second. It's pretty much doing that all day, every day right now, and it's not skipping a beat. So obviously, its peak capacity is significantly higher than that. So that means we're already 3/4 of the way to Visa, and that's with 1 year of effort. In terms of the incentive models, I mean, we're really seeing that start to emerge now because they couldn't emerge properly until transaction volume started to pick up. And again, in the space of 1 year, I think the last check, we were at double the transaction volume of BTC, which is the largest blockchain in the world, in terms of market cap and previously in terms of activity. So that means there are actually some transaction fees on the table. Probably not enough to significantly affect miner behavior if miners are thinking in the short term, but it's certainly been enough now to start affecting the miners that are thinking more strategically about the long term. Mempool's recent deal that they did with Weather SV and I believe others is a great example of that.
Yeah.
And of course, CoinGeek in the background are considering their response to that. They'd already been sort of thinking about this, but there are some exciting things on the horizon when it comes to more dynamic, flexible transaction fee models. Yeah.
Okay.
So the second part of the question, sorry, was.
So the second part of the question was, what does it technically mean to go back to the original protocol? Like what is sort of an overview of the technical changes that you're making, and what does it mean to go back to the original one?
Okay, so we had a workshop here yesterday. Here I'm in Brisbane, Australia right now, and gathered all of the Southern Hemisphere nChainers together, as well as a few of the Australian app developers, which is quite an impressive list actually. Australia's well and truly punching above its weight. So I went through this with them yesterday actually. And I will say that there is a full technical specification, which is currently well progressed, but still work in progress. And we are aiming at releasing that in first or second week of December. But I'll just run you quickly through the list of changes. Okay. I'll leave removal of limits until last because that one really does have some interesting implications. Probably worth a discussion. Okay, the first one is restoring the original functionality of return. It behaves differently to every other opcode right now, in that it causes the script to automatically evaluate to false after the opcode is run. It's not supposed to. It's supposed to just exit the script, and then the script should decide whether it is valid or not based on the rule, the usual rule, which is whether the top item on the stack is true. We had a line item in there to actually restore opcode separator functionality, but after some serious research, it turned out that it actually didn't need to be changed. It's just fallen into disuse and is currently very hard to use because of standard transaction rules. Restore the handling of nlock time and nsequence. Those two fields have been sort of somewhat bastardized to support two new opcodes that BTC Core introduced, which is check lock time verify and check sequence verify. We're cleaning up some of the sort of script behavior. There's a bit of a weirdness in that invalid opcodes, if they appear in a branch of code, so like if then else type block of code that isn't executed, then it doesn't make the script invalid, but the disabled opcodes behave in the opposite way. So there's some sort of inconsistency there. There's a couple of other opcodes that aren't disabled, but that behave in odd ways as well. So just cleaning that up and making it consistent. We did actually consider the notion of making invalid opcodes mean that the script was invalid even if they weren't executed, but after some discussion with Craig, it became apparent that there was actually a really good reason why those invalid opcodes were allowed. The sunsetting of P2SH, Hager script hash, is probably a significant one, and it's the one that actually does come with I guess, a negative impact, because pay-to-script hash is a mechanism that most wallets across all cryptocurrencies currently use to support multi-sig. Now, there are several alternatives to that, and bare multi-sig is only one of them. We'll be publishing a document pretty shortly that is a fairly comprehensive survey of different ways to achieve the same functionality, one of which is just a cool script construct that uses multiple instances of checksig to replicate the functionality of multisig, but adds a couple of additional advantages to it. So the rest of those individual items are actually removing particular limits, things like maximum size of a script, maximum number of opcodes in a script, maximum number of sigops in a megabyte of a block, and that sort of thing. Again, I'll come back to them again because there's a few other non-consensus changes that are required as a part of Genesis. Not in the sense that they're required for protocol restoration, but in the sense that because we're removing a lot of limits, most of these limits were put in place to, I guess, with the thinking of protecting against certain kinds of attack vectors. And some of the non-consensus changes are there to enable incentives to actually manage and moderate these limits to a degree. So one of them is parallel block validation, which means if someone gives you a stupidly large block that takes 3 hours to validate, it won't clog the network up, because in that 3 hours, someone else is going to come along and mine another block. And as long as you can validate those blocks in parallel and accept the first one that completes verification, then you basically create a really powerful disincentive for someone to make mischief and create this silly 3 hour long block. There's a disincentive already built in there anyway, because there's a really good chance that they won't get their block validated regardless due to propagation time. But whilst Bitcoin is, whilst the cost of mining a block is still relatively low, we've still got to consider the fact that someone might just do it, with mischievous intent. So with parallel block validation in place, it literally becomes pointless. They can't stop the network from functioning for any longer than it takes for someone else to mine a block. The other one is, I guess it addresses the same problem, but at the transaction level, which is parallel transaction validation. We've already got that was released in beta in the ARC release a few weeks ago. But we want to break up the transaction validation queues into a set of priority queues and non-priority queues. And the priority queues take all of the transactions that are well-known templates like pay to public key hash, etc. And any template that a miner decides to add to the list of priority style transactions. And what that means is if someone creates a weird transaction that takes a long time to validate, at worst, it's going to block up one of the non-priority queues, and the priority queues will just carry on doing their thing. So 99.9% of the traffic will be unaffected. So, and the last big one, of course, is removing the notion of standard transactions. We're changing that from a whitelist style to a blacklist style check. And that's just because there are certain types of transactions that we know can potentially cause problems, or there might be pitfalls around them. So miners will be able to update those lists themselves dynamically. So that's mainly it. I haven't really gone into the limits yet. That was a really long answer. So.
Okay, yeah, no, that's good. And I've been trying to remember everything you're saying because I have some follow-up questions for some of the details. So let's see how much of this I actually remembered. So first of all, and so what I kind of want to do, I was going to ask all these questions. We'll get to this in a second here, but I just have my own follow-up questions from this. So first of all, for the op return thing, so I guess one way that I would look at this, I guess this is sort of a comment, which is just that, the way that you normally are used to op return, like you return for inside of a function, and in a normal programming language, you have the ability to just return a value at some point. And that's kind of broken right now in BSV or in all of the Bitcoin forks right now. There's no way to do that because the only way to return something is to return false only, which invalidates the transaction. So by restoring this other feature, you get sort of two things out of it. First of all, you have the ability to actually return true at some point. So it just allows you to have a more sophisticated sort of script that people are used to if they're used to programming in a usual way, where you can return something at some point. You can also start to have this notion of actually returning a value that you can then use the value that's returned for stuff, which is its own kind of world of interesting possibilities where you could actually use that value. So I guess that's just a comment, but that seems like, I mean, any further thoughts on that? Like, it's basically restoring this original idea of what return is, kind of brings it back to a lot more like a normal programming language, the way people expect, basically.
Yeah. Well, I mean, in a sense, you are already returning a value because it's whatever is on the top item of the stack. I mean, it's kind of a binary switch. This transaction either passes or fails based on that value. But the original Bitcoin did not have any notion of a clean stack type flag, which has been implemented recently on Bitcoin Cash, which meant that you must have exactly one item left on the stack. You can actually have as many items left on the stack as you want, and they can all be your return values. So it's an interesting point to bring up because it's a piece of work I want the SDK team to pick up very early in the new year, is to actually extract the script engine out of the Bitcoin SV project itself and turn it into a library and wrap it and add a couple of things. One, we want the ability for a script execution to actually return what's on the stack to you, so you can run a script off chain and get the output. You can validate that the script is working because you've seen it there on chain, or a miner's accepted it into the mempool. The other one would be to insert the ability for like debug breakpoints and things like that, being able to peek inside the script engine, which is hugely valuable to people who are trying to work out what's going on in a script.
Yeah. Okay. So one follow-up to the follow-up, which is, so what's the situation with clean stack then? Is clean stack still going to be, is that a rule that's enforced or is that going to go away?
It never made it into BSV.
Oh, okay.
I think it was actually implemented by BCH in their version of November 15 last year. Right. And then I think it was removed again because they worked out that they couldn't recover certain types of SegWit coins that have been replayed or something. Okay. And I think they've gone and put it back in again now. Or something. Okay. Yeah.
Okay. All right. Understood. So that change was never something that happened in BSV. Okay. Okay. So then moving on, I also wanted to just give a couple comments on this in lock time and the in sequence number stuff. So the sequence number was, to my knowledge, basically the intention of the sequence number originally was to basically have a sequence of transactions that are off chain so that you can basically do payment channels. And then this is supposed to be used sort of along with in lock time, where you basically say something like, I'm updating the transactions with different sequence numbers. And then you get to the final sequence number, and then you either that's valid. I'm trying to remember, there's a relationship between sequence number and lock time whereby, like, I guess if it's final, it can go on independent of lock time or something like this. And then there's like, I don't know, somehow you want to keep them off chain where in lock time is not valid yet until it is, and then it goes on chain or something like that.
Yeah, if you set the sequence number to the max int value, then regardless of nlock time, it becomes valid. And on the flip side, after nlock time has passed, it doesn't matter what the sequence number is, the latest transaction is valid. It's interesting, though, that you say off-chain. That's correct. It is off-chain in the sense that it won't get mined into a block, but it can be in mempool. So you can actually create and update the miners with these transactions, and they'll replace.
Okay, well that's interesting then, because this is something that's come up when I've talked about payment channels with developers. So there's a bit of confusion about how it does work and how it's supposed to work. Are you supposed to be able to use the mempool that miners have to update a payment channel before it's valid?
I don't think you're required to. To be honest, payment channels are one area that I have. I probably wouldn't call myself expert in because I just don't have the time to follow up every single facet of Bitcoin. But I mean, from the point of view of these just being a transaction, yeah, they can go into a mempool, which does provide some degree of double spend protection because clients will respect the first rule once it's there. It's not a solution for a long-term channel though, because by default, I think mempools expire after 2 weeks or something. And if everybody's dumping, squillions of these unwindable transactions in minor mempools, they might decide they don't want to do that anymore.
Okay.
So it's a bit of a grey answer, but
okay, I understand. Okay, yeah, and then the other comment I wanted to make on that was just the way in which these were broken by the other implementations. So broken by core, like we have check sequence verify, which overruled the sequence number and use it for something completely different. Or I think that might only be true for version 2 transactions. And then the other one was lock time was used by check lock time verify, which is like an on-chain version of lock time. What's happening with those like opcodes? Are those being what is the status of those opcodes, and are they going to be around? Are they being removed, or what's the situation?
No, they're both being deprecated, and the core reason for that is because they violate one of the I guess the key safety principle of Bitcoin script, which is that it is a predicate. A script should evaluate to true or false, and any given script will evaluate to one of them, but it should always evaluate to the same one. And by design, in check lock time verify means that a script that is invalid now can become valid later.
I see. Yeah, that's very interesting. Okay, interesting. Okay. So then I have another question from the perspective of a wallet developer, which is basically, so we have this library called BSV, that very appropriately named library, which is a widely used JavaScript library for basically creating Bitcoin wallets. My question is something like, okay, well, what are we going to have to actually change in this library? Like, how are you going to handle things like, here, let me pose this as a specific question. When it comes to deprecating P2SH, like, how is that going to work exactly? Like, should we remove the logic of P2SH from our script interpreter? Because we have our own script interpreter. Like, we have a JavaScript version so you can validate transactions if you want to, without relying on Node. I mean, how is that? What are we going to need to change?
I would recommend library remove that functionality for one very important reason. I guess our prime directive, if you want to call it, want to get Star Trekky, is we never make a transaction that was spendable unspendable, and we never make a spendable transaction. Sorry, an unspendable transaction spendable.
Yeah.
So the way that we've approached the deprecation of pay-to-script hash, the reintroduction of big numbers, which I actually forgot to mention in that list, and a couple of other things. The deprecation of check lock time verify is that if the UTXO was created before Genesis activation, then we will evaluate it using the old rules. So if you've got existing pay-to-script hash transactions already in the blockchain, or CLTV, whatever, they will still work. You just won't be able to create any new ones. And hopefully, eventually, they'll all get spent, and we can wipe that code out. But my suspicion is that will take decades. So, you still want one pay-to-script hash support for a while. The main reason, I guess, the main point to make about that is I have spoken to a few people who are under the impression that they would need to move all their funds out of a multi-sig wallet into another wallet before Genesis. That's not the case. You'll be able to move them afterwards. But in terms of being able to make new multi-sig type transactions, you'll be able to basically create any. The only other thing people use pay-to-script hash for right now is to create non-standard scripts. That's the only way to get them into the blockchain. But you'll be able to do that after Genesis, possibly even before, because it's not a consensus change, and it's just a software release that needs to change that. So you'll be able to create any type of transaction you want just in a rule script.
Okay. Okay. Well, that's great, because I'll, speaking as someone who tried to program a bunch of sophisticated smart contracts on Bitcoin, we found that P2SH was a bit of a nightmare, and it just made everything harder. And I'm pretty sure as soon as you get rid of the limits on standard scripts, no one will use P2SH. Everyone is just going to use fancy outputs because it's just easier. I mean, there's basically no reason to use P2SH. So I think that will quickly.
Key observers, something to watch for on block explorers as well. So when Brian X Charles is messing around with some weird esoteric script, someone's going to see it, and the speculation will start, and the rumor mill will go into overdrive.
That'll be cool. It'll be like the Alice in Wonderland of scripts, I guess. Okay. Okay. And then the rest of the stuff you were talking about was basically the impression I got was something like, you are very aware that when you start removing limits, you might be opening DOS attack vectors, and basically you're creating optimizations in the software at the same time to, rather than have the limits, you basically are making the software better. I mean, like you're talking about things like parallel transaction validation, and I forget the words you use, but there's something like a way to parallel block validation. So you've got like one block being validated while another one can be validated, things like this. It's ways to basically, if you have enough hardware, because it does, it would require, rather than just placing a low limit, you actually would have to have the hardware to be able to validate multiple blocks at the same time. But it's a different approach. Is that a fair way to summarize what you're doing? Like you're basically making the necessary optimizations in the software so that you can remove the limits.
Yeah. So, I mean, a general approach to this was we wanted to move all of the consensus limits as a first step and make them policy limits, or rather what we're referring to now as local policy. So I, as a miner, can choose that I'm not going to accept a transaction larger than n megabytes. But if someone else mines it into a block, then I will accept it. So if all the miners have the same policy, then it sort of becomes a wall. But it should be certainly needs to be miner configurable. But as we were going through the limits one by one, we realized that most of these limits were addressing one or more of a limited set of DOS vectors, and they're all resource exhaustion attacks. One is CPU exhaustion, memory exhaustion, network bandwidth exhaustion, and storage exhaustion. Storage rarely comes into play because if you get to a point where someone's running out of disk space, they've probably already run out of memory or network bandwidth before they kind of get that far. So we've replaced all of these limits at a policy level with four mechanisms, and then at the consensus level, there's slightly different mechanisms. So there's a maximum script execution time policy. In fact, there's more than one. There's a max script execution time for the priority queue, which we should be able to set very low, in the order of like a millisecond to 10 milliseconds. So if a transaction is validating and it exceeds the threshold, then basically we stop validation, and then it actually will get kicked into the low priority queue, which will have a much higher threshold, several seconds, 10 seconds, 20 seconds, whatever the miner decides. And if it still doesn't validate in that amount of time, then the miner just won't mine it. They'll validate it if someone else does. The next one is maximum script memory usage. So a script that is a megabyte long can actually cause memory usage of much more than a megabyte, because you can push a chunk of data onto the stack and then you can duplicate it and do other things to make it bigger. So there's a max script memory usage policy there, which we're initially going to be setting to a very large value, something like 100 megabytes, bearing in mind that this is there'll be multiple threads executing these scripts at once. So 100 megabytes, if you've got 10 cores, means that you could be using up to a gigabyte. And well, those actually pretty much boil down to most of them. So the maximum block size, there's still, I mean, that's still set as a policy. But the actual block cap itself, the consensus block cap, the one that we all spent years arguing over, we're not actually removing that altogether. We are changing the default to infinite. Well, actually 0, which means infinite. So miners will still be free to set that. And what it really comes down to is a choice for the miner between, if my software can't, and basically if my software has to load a whole block into memory, which it shouldn't have to do, not once it's engineered properly. If someone sends me a block that is too big, do I want to let my node crash because I ran out of memory? Or do I want to reject the block and start mining a fork? And if I start mining the fork, then it really comes down to whether the majority happen to be in the same boat as I am. So it really creates this kind of interesting dynamic where one miner on their own can't sort of leap out ahead of everybody else. They've kind of got to wait until a majority have caught up. So there'll be this sort of critical band. I guess the median band, and there might be an outlier at the bottom who will have gotten forked off the network, and an outlier at the top who can't quite act yet. But the pressure will be on for the those boundaries of that band to move upward and upward and upward. And if you can take a pretty solid guess that more than 51% of miners are now able to handle a bigger limit, you've actually got a pretty good incentive there to do it, because you might be forking 45% of the miners off the network and increasing everybody's market share by 45%, which is a pretty potent incentive. Yeah. And you would expect pretty soon after that, Amazon will be receiving a few orders for RAM chips, and the miners that got left behind will be upgrading. So.
Okay. All right. Well, that's extremely interesting. There's just a lot of like, you have to think through I guess you would say the incentives of it. I mean, like the miners have to be very thoughtful about, where they set their own limits and what they think they can handle and things like this, and have to be smart enough to know something about the other miners, because they can't act too out of line with the other miners, or they're just booting themselves off, I guess.
Yeah, it's one of those interesting questions that raises the fuzzy boundary between cooperation and competition. So I've been wrestling in my head with the idea of whether the miner ID document, miner ID basically allows miners to publish a signed document in the Coinbase transaction, and they can make statements in that, or declarations rather. I've been umming and ahhing about, well, should we give them the ability to actually publish what their maximum block size, their hard caps and their soft caps are, so that they can look and see where's the sort of, the median, I guess, of the network, and what are the outliers. Yeah. And the conclusion that I came to is I should give them the ability to, but not make them. They can decide for themselves whether it's in their best interest to tell others what they're doing or not.
Yeah. Okay. All right. Great. That's extremely interesting. Okay. I think that I've got a huge list of questions here from, so I asked people on Twitch. I told them I'm going to be interviewing Steve Shadders. Can you please let me know what you want me to ask him about the Genesis upgrade? So I've got some very interesting questions here. So maybe let's just go through some of these. Some of them are for me, but most of them are not for me. Most of them are from other people. So first of all, Daniel Krawitz asks, are there any opcodes that will be turned on?
Turned on. There's only 2 opcodes that haven't actually been restored yet. And they're kind of what I call slightly redundant opcodes. I do want to get them turned on, but they're opt2 mul and opt2 div. So basically they do exactly the same as if you pushed some number and then 2 onto the stack and then did opt mul. Okay. They save you 1 byte, which there are actually cases where that does matter, especially if you were doing say, elliptic curve point addition. There's a lot of raising to the power of 2 involved, and if you have to do it, 10,000 times or 1,000,000 times, you cut the number of opcodes in half.
Sure.
But it just didn't make it to the, I guess, the high enough on the priority list to get into Genesis. So there is definitely going to have to be at least one more hard fork. I'm hoping it will only be one, but it'll be full of minor things like that. And in terms of stability, I don't think it's actually going to affect anybody, because most of these things will be expansive changes. They're not going to stop anyone from being able to do something that they can currently do. They'll just allow more things to be done.
Okay. All right. Very interesting. Okay. All right. Let's see. Okay. So you sort of answered this. I'm going to ask it anyway, just in case people are curious. So in regards to sunsetting P2SH, what is a reasonable time frame expectation of security that I might expect from an existing paper wallet, which was created prior to the Genesis upgrade and intended for long-term control storage? 1 year, 2 year, 5 years, etc.
I'm assuming they mean that it's a multi-sig wallet, and if that's the case, then deprecating P2SH won't change that at all. However long it was going to be secure for before, it will still remain secure for that amount of time. Yeah. So eventually, I mean, if you leave it 10 or 20 years, you might find it a bit tricky to find a wallet that actually supports multi-sig. You might have to get someone to custom code it for you. But if you leave it 10 or 20 years, you're spending a few $1,000s getting someone to do that might not be a big deal to you. Okay,
sounds good. So I hope that eases some people's minds. Okay, so this is a question for me, actually. One of the questions I had is just, what is going to happen with the SIG hash algorithm? Are you making any changes to that? Is that staying the same? Is there any intention to return to the original SIG hash algorithm?
Yes, there is. I left that one off the list before too, so glad you brought that up. So just a quick bit of background. When Bitcoin Cash came into being on August 1st, 2017, they implemented a different SIG hash algorithm, and there were 2 reasons for that. One was because the original one was subject to, I guess you could call it an attack vector, which is a quadratic hashing problem, which basically meant the time it took to hash something was would increase exponentially the more inputs that you had. And they found a way kind of around that, I guess, by changing the SIG hash algorithm. But there was still a whole bunch of signatures from pre-2017 in the chain, so they actually had to support a similar mechanism to what we're doing with Peter's beta script hash, where which type of signature is allowed is based on the height of the UTXO. So you can spend transactions that were signed back then, but you can't if they were in the chain, because that now associates them to a UTXO height, for which that rule is valid. But if you've got offline transactions, for example, if you created an n-lock time transaction with a 10 or 20 year window or something, which is sitting on a hard drive or something somewhere waiting for you to broadcast it at some point in the future, those will no longer be valid. So the point of this change is to make it valid to use that original signature SIG hash algorithm for any transaction, and the only restriction on it currently is that it can only spend UTXOs that already existed before Genesis activation. The thinking behind that is it means you can't prepare a quadratic hashing attack, I suppose, now. You can't go make new UTXOs that you can then feed into a quadratic hashing attack. You can only do, I mean, if you happen to have done it and prepared beforehand, then yes, you can probably get away with it, but there's a limit to how many times that can happen, and probably nobody has. Having said that, my thinking around this is sort of changing somewhat of late as we've gone through this process of mitigating attack vectors with limits, etc. I'm actually starting to think maybe we should revert to the old SIG hash algorithm, because exactly the same mitigation measures that work against any other long-running script type attack are applicable to to this case. So
I see.
you've got a pretty powerful disincentive to create transactions like this, because there's a good chance they won't get mined. They'll get ignored.
Okay, that's very interesting. Yeah. So you effectively found a different solution with this idea of timing things out and letting that be a minor policy. And you could imagine using that for this quadratic hashing problem as well. Is that what you're saying?
Yeah. I think it'll take a lot of thought, and obviously not going to happen for Genesis. There's no time to think it through properly, but it could be part of the following one. But it would have the interesting and no doubt horribly controversial effect of removing the replay protection between BSV and BTC.
Yes, that would be it would be very interesting. I mean, it's yeah. Okay. All right. So, okay. So let me, I sort of mostly understood what you're saying, but I still don't know. You're saying it will not actually be changing at Genesis, like the SIG hash algorithm will stay the same. Is that correct? Or did I miss something? Yeah,
well, there's two SIG hash algorithms. Neither of them will be changing, but the original SIG hash algorithm will be valid in situations where it currently isn't.
Okay, I understand. Okay, so you're
it will allow you to take offline transactions that you currently can't spend on BCH or BSV, and you'll be able to be valid. Yeah.
Okay. All right. That's interesting. So that's something we have to be sort of aware of that for our library. Because I guess if we're going to do things like validate a transaction, that opens up a new type of valid transaction that we have to be able to validate.
Yeah.
Okay. All right. Let me. I
might point out, as a library, you don't actually have a responsibility to be able to validate every single transaction. I mean, a wallet usually can't handle certain types of transactions. There's only a limited set that they can handle, and that's actually fine for a wallet. It's actually only the miners that need to be able to validate every transaction.
Yeah, that's a good point. You're right. And if there's no practical reason to add that, then we don't have to add that. That's a good point. Okay, I'll just say from the perspective of a browser wallet, the smaller the library is, the better. So certainly if that's not something that anyone needs, we don't need to add in more code. Okay, so this is actually not the next question, but I just want to ask this anyway, which is a related question is the difficulty adjustment algorithm. So what's happening with the difficulty adjustment algorithm?
Nothing in Genesis, but it's, when I say there'll be at least one more hard fork, it's largely to fix that. When transaction volume increases, then the attack that you can currently do on a 2-week difficulty adjustment cycle basically becomes a moot point. It's another really nice example of how scaling actually makes Bitcoin far more resilient. Yeah. So the attack that I'm talking about actually has been done by a certain miner on BTC to several altcoins and caused a chain death. Basically, you take a huge amount of hash, many multiples of what the other coin has over, and you start mining it, and you push the difficulty up and up and up and up, and then you bugger off again. So now they're reduced to a hash rate that represents about 1% of their difficulty, and it takes 1,000 minutes instead of 10 minutes to mine a block. So you're up to a year or 2 years or however long before a difficulty will adjust. But difficulty can only adjust down by 75%. So you might actually have to go through several of these difficulty adjustment periods. Now, when you've got lots of transaction volume, that ceases to matter. And in fact, it matters even less when you're in a world where zero-conf transactions are considered safe. Because as time goes on, the amount of revenue, the reward revenue for the block builds and builds and builds, because more and more transactions are backing up in the mempool. And eventually it gets so big that even BTC miners are incentivized to stop mining BTC and come over and help BSV. So from our point of view, I'm actually not that worried if we have a 4-hour or a 12-hour interval without mining the block, because zero conf on BSV will be so safe by the middle of next year that it's really not going to affect anyone. Unless maybe they're buying a house or a Lambo, in which case I've never seen a settlement go through in a few hours. So it's not going to bug anyone too much. but yeah, it will actually end up being the BTC miners through their own self-interest that will help to undo an attack like that. So basically, it comes down to once we've got enough transaction volume, that it's safe for us to put the difficulty algorithm back.
Okay, so that won't be changing in Genesis then, but that is something that's still a candidate for a future hard fork post Genesis, is what you're saying. Yeah. It's a very interesting argument there.
It's definitely going to happen. It's a question of when.
Okay, interesting. Yeah, and I love the idea that it's one of those things that when you think through how all these things work at scale, a lot of things make a lot more sense, and that's one of them. That basically, when you can just handle really large blocks, the problem of large block intervals just matters less. So, okay. All right. Here's another one. There's a error that we often get in the node software that says too long mempool. That occurs when you have basically a long chain of unconfirmed transactions or a short chain of transactions that have a lot of data in them. So what is that about? And are you guys going to help us get rid of that error?
I would have been stunned if an interview went past without that question being asked. It's been asked in almost everyone I think I've had all year. This is very clearly the highest priority issue for people out there in the space, and particularly in the app development space. And it's been on our radar pretty much since day dot, because people started asking for it, even before the hash war last year. The short answer is we've been working on it, but it is a problem that is the actual bit that we need to fix is buried under several kind of layers, and we've had to sort of peel those layers back one by one. Outside of Genesis, it's been our highest priority. The final fix for it, the final fix from my point of view is where there is no limit at all. And it's very, very feasible to do that, because adding a transaction, if you think about these transactions in a chain, if I've got a chain that's 25 long and that's 24 long, and I go and add the 25th, all I actually need to know is that number 24 is valid, because by implication, that means that 23 is and 22 is, and so on, all the way back to 1. That's all the software does right now, and this is another consequence of small block thinking. It actually, if I add number 25 to the chain, it will actually go and do a check that visits all 24 previous ones, and then 26 visits all 25 previous ones, etc. So it's exponential cost. There's no reason for it to be. The only reason it is because when you've got 1 megabyte blocks and you've got a 10 megabyte mempool, you've got to choose the most valuable set of transactions. But if your default is to add every transaction to the end of a block, there's no need for any of this messy filtering. And there's currently about 3 kilobytes of overhead per transaction for indexes and various other data structures that are all there just to solve this non-problem. Getting back to the answer, the final solution to it is probably it's probably February, March-ish kind of next year. We think we've got a shorter term solution to at least being able to raise it, in that we've changed the way that building block templates works. It actually runs in a continuous cycle in a background thread now. So when you ask for a block template, you get it straight away. And this was primarily where this problem manifested. If you had really, really long chains and lots of them in the mempool, you'd ask for a block template and it could take minutes to get one back, especially when you're talking about really big blocks. So we've kind of solved that problem now. So actually, as a result of this exact same discussion that I had yesterday in the workshop, Brad, the STN manager, was here. We started talking through it, and he's actually gone and started tests today of a 100 limit on the STN. Depending on how that goes, if it goes really easily, then we'll try a higher limit, etc. And on that basis, we might be able to get the miners to change that or increase that setting sooner than later.
Okay, great. So if I could just summarize, and what I'm hearing from you is there's a good chance, but not a guarantee, that there'll be a raise to the limit in Genesis. And then no matter what happens, you are committed to fixing it, and hopefully not too much longer after Genesis, there'll be a complete solution. Is that a correct summary?
Yeah, and the complete solution will be that there is no limit.
Okay. Okay, great. All right. Well, that's wonderful. And yes, it is a very common complaint for us, because it's very common complaint from our users.
Yep.
And it'll be wonderful when that's resolved. Okay, let's see here. Moving on. Okay, another question is, what's going to happen with fees in terms of how they're determined? Because one of the interesting properties of BSV right now is that there's basically just a fixed fee, pretty much, with a few caveats, like the deal with WeatherSV and mempool and stuff like that, where they can have a custom deal. But for the most part, people are paying a fixed fee of 1 Satoshi per byte, which is very weird, actually, because the price of BSV changes. And so the effective fee rate that you pay actually depends on the price. So it can start to feel a lot more expensive. We notice this a lot with the apps. Like if you're writing data to the chain, the price of BSV increases, means the cost of writing data to the chain also increases. So the question is basically, what is the situation with allowing the fees to vary or be determined by individual miners?
Again, as a subject we went into in a lot of detail yesterday, because it's a hot topic amongst app developers, especially with recent price rise. Notably, we didn't hear too much noise about it when the price dropped, though. They had no complaints then. So there's a couple of ways that we can attack this. And I guess there's two things that are kind of on the horizon, which will probably emerge around about the same time, and one will make the other redundant. Something that the SV team was working on a while ago, which is I think has made it to QA stage. It's code complete, but hasn't QA'd, was the ability to price data bytes separately to the rest of the transaction. And my assumption would be that the data bytes would probably be cheaper. But going through that process really highlighted to me how brittle and hard to change that code is when it lives inside Bitcoin SV. I mean, Bitcoin SV itself, just for the nature of the project, it has a fairly slow release cycle, very onerous QA process, etc. And from the moment you go, okay, we need to do this, to when it's actually available, it can be quite some time. So the Merchant API, which I've been talking about at various conferences for all year, is pretty much ready for beta testing now. And one of the first improvements that we want to make over the initial version is, which requires a change in Bitcoin SV, is for SV to have the ability to take a trusted connection on RPC and accept a transaction and not do any fee checks at all. It trusts that whoever has sent that transaction, which would be another service operated by the same miner, has done the fee check. So it will just accept the transaction into its mempool and start mining it. So what that effectively does is it takes that whole fee evaluation logic out of the Bitcoin SV node, and it can be done, in another place. Now, Merchant API just happens to be a logical place for us to do it, but it doesn't need to be. It can be done, anyone can build their own fee evaluation module. But once you do that, things start getting a whole lot more flexible, because Merchant API is a REST API. Lots of REST APIs have user authentication. So you could do things like apply a different fee policy for different users. Mempool's recent deal with WeatherSV would be, a clear example of that. They're offering them a certain rate, and they might want to offer different rates for different people. As a miner, I might consider weather data to be more valuable data because it's a public good, a public utility. Then I might think that's more valuable than, say, your pictures of your cat, because that's useful to you, but not to everybody. So, mempool might want to give WeatherSV a lower rate than they give to other people for data usage. But that's just sort of the beginning. I mean, this fee evaluation module can be anything you want. You can modify fees to keep them stable in fiat terms. You can have your fees update every hour or every minute or every day or whatever you want. People can invent new ways of evaluating fees based on the number of math opcodes in them or something like that. The sky's the limit. So that's another thing that we kind of want to open up. The last thing I'll say about that is I have actually already been talking with CoinGeek about this, and I'm meeting with them as soon as I get back to London, actually, on precisely this topic. I think fiat stability of fee pricing is a topic I think that's pretty high on people's agenda. I think it's well understood why there's a need for it. So I would expect a solution to that sooner rather than later.
Okay, all right. So what I'm hearing from you is you clearly have worked a lot on this, but I'm not hearing a guaranteed solution inside Genesis. Is that correct?
I would predict that we will have a solution that solves most 99% of the problem before Genesis. It might be a bit kludgy, but
okay, great. Okay, before Genesis. Okay, well, wonderful. All right, that's fantastic. That's going to be very interesting to see that then. Okay, so let's see here. There are some humorous questions which I'm not going to ask you. I'm going to ask only serious questions here. Let's see. So we've covered a lot of this. Okay, here's a very concrete technical question. So what will be the maximum op return size after the upgrade?
Well, the maximum op return size is actually a function of policy. Any miner can change it. But it's a bit more tricky than that because so many more people other than miners are using Bitcoin SV right now simply because the functions aren't available anywhere else. So it makes it a bit trickier to relay. I have to go back and double check if we've actually changed the default limit again. Having said that, if we haven't, then it could be relatively easily rectified by miners getting together and doing exactly what they did back in March, and increasing it further. So yeah, I can't actually give you a definitive answer on whether we've done that work or not.
Okay.
Having said that, a couple of other things though will become possible in Genesis. One of the reasons why that was possible without a consensus change, or actually one of the reasons why I thought that we couldn't do what we did in March, was because there's actually a consensus limit of 520 bytes maximum in a push data operation. And the big revelation, and the reason we realized we actually could get rid of the limit right now, was because after you hit an op return, the script stops executing, so it never actually checks whether those limits are exceeded. So now, because we're actually getting rid of those limits, you'll be able to use push data in a lot of different ways that you can't currently do now. So you can embed data in spendable outputs, not necessarily even using op return, and you won't be limited to 520 bytes. So I expect people hopefully will start experimenting with different ways of embedding data in transactions. Okay, very interesting. Okay, so yeah, so if nothing else, we have the ability to basically use push data inside other outputs and inputs, I guess, to experiment with storing stuff. Okay, that's yeah. A simple way to do it would be take a normal pay to public key hash script and at the beginning push data and then drop. So this you put it straight on the stack and drop it straight off. It doesn't affect the workings of the script anyway.
Okay. All right. I'm going to rephrase a question here. I'm going to ask this person's question a slightly different way, which is, the question is basically like, what limits are going to remain at Genesis? And I want to preface this by saying, I think of there being several different limits. There's the block size limit. There's the limit on the size of a transaction. There's a limit on the size of scripts. And I think I think those are the most important ones. There are a number of other limits, but what's actually going to happen with those limits? So is the block size, you said, is being basically converted into what's infinite. There's still a block size cap, but it's infinite and it's a policy. Can you maybe just summarize what is actually going to be the limits on those things after Genesis?
Infinite by default. So miners will be able to set their limit, and it comes down to a choice for the miner what they want to do if their physical capability is exceeded. Do they want to crash, or do they want to try and fork? I would expect most miners would probably want to try and fork. So there are. I wanted to remove all limits, at least at the consensus level. But there were a couple that it turned out it was not possible to remove them altogether. We were able to set them very, very high. The first is the maximum transaction size. We elected to set that to 3 gigabytes by default. The reason being that there is a de facto limit on the size of a block based on the peer-to-peer protocol. So the peer-to-peer protocol uses a 4-byte field to indicate the length of a message, which means the maximum size peer-to-peer message you can currently use is 4 gigabytes. Now that, in the very short term, constrains the size of blocks, because if you make blocks bigger than 4 gigabytes, that's fine as you're making them, because we use compact blocks, which compresses dramatically the amount of data that you send around. But for initial block download, it's a bit more problematic. So we need a second version, I guess, of the peer-to-peer protocol that uses a larger field for that size, and for initial block download to make use of that. So with that de facto limit there in place, we decided, well, we better make the transaction limit a bit less than the size of a block, and we just picked 3 gigs as a round number. Hopefully by the time we get around to fixing that, people won't have found too many use cases for 3 gig transactions yet, or at least it gives them enough flexibility. The other one is in the maximum size of numbers that you can use in math operations. This one I was a bit disappointed about, but there wasn't much we could do. It's basically an inherited limit from OpenSSL. The maximum size numbers that it will allow, it's actually platform dependent, so it's a different limit depending on what platform you're on. So we picked the lowest one. And I can't recall off the top of my head if it's 64 megabytes or 128 megabytes. I don't think that's going to preclude too many use cases. The largest known prime number is like 28 million digits long. So I'm pretty sure that if we can encapsulate the largest known prime number, then there's not a lot of use cases there that we'll be locking out. So we have to figure out a longer term solution for that one. And the last one is actually a new limit, which is the maximum script memory usage, which we furiously debated internally about whether we should actually make that one a consensus limit, but it has the same properties as the maximum block size, in that if it's exceeded, the miner has a choice between crashing or try to mine a fork. So that limit will be there, but again, it will be set to 0 default.
Okay. All right. Interesting. That's a wonderful overview of all those. Okay. Let me find other ones. This is another question for me. You sort of answered this, but so you do have some transaction, parallel transaction validation code in the new Node software. Is that correct?
Yeah, the last release, the ARC release a few weeks ago, which is still in beta, it'll be upgraded soon to stable, had the structural changes for parallel transaction validation. It is in fact validating in parallel. Yeah. Okay. There's a lot of low-hanging fruit now, though, for us to grab, which will bring yield, very substantial performance.
So that must have been a pretty large change, right? I mean, that must be a very, because it does seem like in principle and clear that part of the answer to scaling is just do things in parallel, but apparently that's not quite so easy.
No. I mean, it's terrifying code to touch, especially at a deep structural level like that. The work on that started before June, I think. So there was several months of actually doing the initial code, and there's probably been 2 or 3 months, I think, 3 months of code review before it even got into the QA process. So it was something we had to treat really, really carefully.
Okay. All right. Very interesting. Okay. I see somebody else asking the mempool question. So it's a popular question here. Okay. Here's a question. This is actually from Mige, a Moneybucks developer. What is the plan around creating docs, like documentation for the node and the protocol? He says, right now, where I need documentation, I usually read old BTC docs or read directly the source code. It'll be nice and super handy to have good documentation about the BSV protocol.
There's a few different answers to this. The first is there's a GitHub repo called Bitcoin SV Specs, which has been sort of lightly used lately. Well, we use it for email actually, but it has an empty repo there for protocol as well. So all of the changes for Genesis are being written up into proper detailed specs, and we're aiming to release those by end of first week of December. So they'll all land there. The rest of the protocol, we actually kicked off a project last year that kind of got stalled to document the entire SV protocol in detail. Well, at the time, it was the Bitcoin Cash protocol. There's a substantial amount of work has been done on that, and we'll be hoping to pick that up again by after Genesis. And in the background, there's another documentation project that we're actually working on in conjunction with Bitcoin Association to hopefully fill a substantial part of that gap. But it's a big chunk of work, and I think we'll probably have more to say about that in the new year.
Okay, all right, sounds good. Okay. All right, one final question. We kind of covered part of this, but I'll ask it anyway just to get your thoughts on this specific question. What are the key improvements in the node to be able to handle really large blocks? Is there any original technology development that you can mention?
Original technology that we can what?
That you can mention. I mean, what are the, I guess, it's sort of, we already covered that. There, of course, there are changes that you're making to handle large blocks like parallel transaction validation and all these things. But what, I mean, I guess, so the question is, what, is there original technology development that we want to talk about with respect to handling large blocks?
Oh, I see. Look, at Bitcoin SV node itself has a limited lifespan simply because of its architecture. It's architected as a monolithic implementation, and it's less than 1% as efficient as it can be. So there's huge gains that we can get out of it, and it can carry us for no insignificant amount of time. But I mean, I would estimate somewhere in the region a few hundred gigabytes, or even 100 gigabytes might be its limit. In order to address those things, you need to kind of re-architect the whole thing, which doesn't mean you need to chuck all the code out. But right now you've got horrible things like the network thread sharing a lock with the validation thread, and there's no real reason why that should be the case. It's just a mess of data structures that are intertwined when they shouldn't be. So Dan's started work on that already with working on the peer-to-peer layer, peer-to-peer agent that can basically be scaled up using something like Kubernetes to just wind up more and more nodes in the cluster of the kind of the single sort of Terra node. I've done a bit of work around UTXO stuff myself, which has been parked for quite a while, but it was a fun Christmas project I started in Christmas break last year to back the UTXO in a Redis database, which leverages all the sharding capability of Redis, etc., and lets you scale that up nicely. We've done little bits of work on other components. It's proof of concept level, but I've got a signature validation server which I wrote, which just basically lets you spit transactions at it, and it gives you a yes/no answer whether the signatures are valid. So it's about breaking up and separating all of those functions. And as you go through that process, you really get a clear understanding, I guess, of the interdependencies between transactions. And it's really led me to understand that Satoshi really thought through the scaling use case, like right from the beginning. Like the way that Bitcoin is designed makes it quite easy to architect a system that can implement a protocol that is very, very parallelizable. If you think about like the design of a block, for example, there is no reason why a transaction at the beginning of a block and a transaction at the end of the block couldn't be validated in parallel unless they happen to have a parent-child relationship. It's one of those clues that you really don't get to see until you've really, taken a very deep dive into the software and tried to make it parallelizable, that you can see how clearly Satoshi was thinking about this, right from the beginning.
Yeah. Okay, that's very interesting. So, okay, so then one comment on this is just you're basically saying, I mean, something you guys have already started, but sounds like it will be quite a long process to see it through, is this idea of breaking up the monolithic application into a number of smaller components, where you've discussed things like the idea of computing the fee beforehand in a different piece of software. That's like separating that part out. And then you can imagine separating out many of the other components so that it's no longer monolithic and it's broken up into smaller pieces. That's sort of the vision there. Is that a fair way of describing the future? It's like
yeah, pretty much. I mean, a lot of the bits of code can be the existing code can be wrapped up inside those sort of separated components. Because once you have a clear understanding of where the interdependencies lie, and in the validation process, there's only one point where there is one, and that's the double spend check. Then it really becomes clear what you can break up, and what you can't. And it turns out most of it you can.
Okay. All right. And then the other thing is just that, so it's very interesting to hear your thoughts on the smart design of Bitcoin from a parallelization perspective. Because I too have thought about this a lot when I keep coming back to just telling people why we're using BSV. Because I don't see any fundamental scaling challenge. I see a lot of challenges to scaling it. I see like an engineering challenge, but it does strike me as being fundamentally parallelizable and therefore scalable in a way that many of the other ones aren't. It's just interesting to hear your thoughts on as you go into the insane detail that you've gone into, that you still see it that way, that yes, it still seems like, it seems smartly designed, from the beginning to be parallelizable and therefore scalable.
Yeah, it certainly does. Actually, one of the more amusing moments, I think, in one of the earlier Terranode workshops that we had, we were considering the problem of Merkle trees, and how Merkle trees are a wonderful data structure for this kind of use case, because of the fact that if you operate them in append-only mode, you can update them all very efficiently, etc. And at one point, we considered the possibility, what if after every single time we added a transaction, we had to sort this entire list that was probably spread across many, many machines? And the idea just horrified us. And of course, I don't know if anyone has made the connection yet, but why would you need to do that? Well, you might need to do that if you had some kind of required transaction ordering in your block.
Hint, hint.
Yeah.
Okay, very interesting. Okay, all right. I think that's it for all of the questions. So, Steve, this has been extremely, extremely informative. I really appreciate you did this. I mean, this has answered tons and tons of questions about Genesis, so this is really helpful. Do you have any other any comments or questions? Anything you want to add about Genesis?
I guess. Yeah, maybe a word of encouragement to people to come along and participate in testnets. So you'll start hearing a lot more noise from us over the next couple of weeks about Genesis. I mentioned the specs will be published, etc. We're aiming to have 2 testnets available, public testnets available by end of this month, hopefully. And they're public for a reason. We want people to come and test their applications on it. So one testnet will be set to post activation, so it'll implement all the Genesis rules from scratch, and the other one will be constantly resetting to just before Genesis and then passing through the transition. So please get involved in those and get involved in the discussions, and when the specs come out, jump in and comment on them. I would like to have had them out earlier so that we could have had a wider sort of community discussion about them, but I'll be doing my best to explain the rationale behind all of them, all of the changes, etc. And I expect I'll be, talking to people in more public arenas quite a bit over the next couple of months, because it's a big change and it needs to be, explained and well understood, especially the people that might be involved with multi-sig
Okay. Okay, great. All right. Well, that's fantastic. Steve, thank you very much for your time. And thanks a lot for the information. And I guess talk to you soon.
Sure. Been a pleasure to be here.
All right. Take care.